Let's get back on here. Okay. So we have Donald Duck over here, and our first introduction to this section is talking about punting a football, okay? So the height of a punted football can be modeled by this function, okay? Y equals negative 16x squared plus 10x plus 2, blah, 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 okay? Where y is representing the height of the football. Do you know what x is representing?
The distance.
Nope, not the distance. The time after it is kicked, right? The time after it is kicked, okay? The graph of the function can tell you how high the football is during its rise and fall, and when, that's the other variable, that's telling us that the x variable represents time. So we're doing everything in relationship to time, okay? So here's what's happening.
It'll be a parabola.
It will be a parabola, right? So that's the next question that I have for you. This guy, his parent function is y equals x squared. We talked about that the other day. If I strip away all of the numbers, x squared is the highest power. Okay, which looks like a parabola, except what?
It'll be up.
It will be what?
It'll be pointing down.
It'll be pointing down. Do you know why?
Because it's a football.
Because it's a negative in front of the equation. So that means it's doing one of these, and it's going like that, right? Okay, because that's kind of the path that a football takes, right? It goes up, and then it comes back down, all right? And so that's how this thing is working out here, all right? What I'm going to be able to do is I am going to be able to plug a number in for x, and it will tell me the height that the football is at, okay? So we're gonna plug a number in. It's gonna be kind of a weird number, or a weird answer that we get out, and I'll kind of explain that to you here in a second. But let's say I'm interested in finding out where the ball is located 2 seconds after I kick it. Okay, 2 seconds after I kick it. So what I'm going to do is I'm going to plug 2 in for y.
You mean x?
Or excuse me, 2 in for x. And we do it like that, right? Okay, are you plugging all this in, Caitlin? You getting an answer for us?
Yeah.
Uh-huh, what'd you get?
Hold on, I'm still typing it in.
It says 21. God.
It's negative 42.
Negative 42, okay. Wait a minute. The height, hold on.
It's under the ground.
Right, the height is at a negative 42. Okay, so listen to this real quick. 2 seconds after this ball is kicked, the height is at a negative 42. That doesn't make any sense to me. What does that mean?
It's negative 2 feet high. Or negative 42?
No. Negative 42.
21 up, 21 down.
No, negative 42. 2 seconds after I kick it, it's at a negative 42. That's where the parabola is, right? But keep in mind that your parabola does not continue to go on forever and ever and ever down underground, right? Okay? So what's happening with this is, since I'm getting a negative answer, 2 seconds after I kick the ball, what's happening is this ball is not in the air for 2 seconds. It is in the air for less than 2 seconds, right? Does that make sense? Because by the time it hits the ground, 2 seconds is beyond that. So it's negative 42 at 2 seconds. That means the ball has touched the ground before then, right? So we're talking about the ball not being in the air for very long, okay? We're going to discuss this more in depth in example 3, but let's talk about...
What if it's in minutes?
What do you mean?
What if it's in minutes?
I don't know. That's a good question. But that would be way too many seconds if that's the case. I don't know.
I think 2 seconds is not long enough.
I don't know. Anyway. All right. So first example, it says find x and y intercepts. Find the x intercepts and find the y intercepts. Okay. Off to the side over here, let's talk about those real quick. This is how you can remember x and y intercepts. Okay. I'm going to plot some x intercepts for you. What is an x-intercept, by the way?
Wait, so
it's on the x-axis.
On the x-axis. So here's an x-intercept. Hold on. Here's an x-intercept. Here's an x-intercept. Here's an x-intercept. Let's say that this guy is the point 2, 0. Let's say that this guy is the point 6, 0. Let's say that this guy is the point -4, 0. We don't know. And each one of those is an x-intercept. Okay? Now, there is something common about each one of those points. What's true?
0 for y.
The y coordinate is 0. Y equals 0 if you're looking for the x-intercepts. That is true. Okay? So if we're trying to find the x-intercepts, we would just plug 0 in for y. Okay? So let's go down to and let's talk about the y-intercepts. Okay? So I'm going to do that down here. This is a y-intercept, this is a y-intercept, this is a y-intercept. Let's say this guy is the point 0, 3, and this guy is the point 0, 7, and this guy is the point 0, -5, right? What do each one of those have in common? Those are all y-intercepts. The x is 0, right? So if we're trying to find x-intercepts and trying to find y-intercepts, we plug 0 in for
One of those.
the opposite one, right? If I'm trying to find the x-intercepts, I plug 0 in for y. If I'm trying to find the y-intercepts, I plug 0 in for x. Does that make sense? Because that's true for all x-intercepts and all y-intercepts. Isaac Mackey, you need to turn around. Shush. Shush. You cannot afford to not listen. All right.
Yeah, Isaac, you're
Find the x and y intercepts. Shh. Here we go. I'm going to do x intercepts over here. And I'm going to do the y intercepts over here. Okay, so we're going to do like a division symbol here. Okay. And just because y-intercept is easier in this case, I'm going to do the y-intercept first. Okay, so this is going to be the first one that I'm going to do. And to find the y-intercept, what did we say?
X gotta be 0.
Plug 0
Oh,
for x.
yeah.
Plug 0 in for x. Okay, and this is the equation that I'm doing. I'm plugging 0 in for x. Okay, so starting with y equals 1/2 times 0. I'm plugging 0 in for these x's right here. 0, 0, plus 1/2 times 0 minus 6. That's what he will look like. I'm plugging 0 in for those x's in that equation. Are we confused as to what we're doing?
No.
No? Okay. What is 1/2 times 0 squared? Like, what's this going to be?
0.
0. Anything times 0 goes away, right? What's 1/2 times 0?
0.
0. So the y-intercept is
Negative.
-6. If I write this as an ordered pair, it would be 0, -6, right? 0, -6. So I'm going to put that point on my graph. 0, -6 is this guy right there. Okay? All right, happy with that?
Yeah.
Maybe a little bit. Okay? All right, let's do the x-intercepts. Okay? And to find x-intercepts, we plug 0 for y now instead. Okay, you plug 0 in for the opposite. So if I plug 0 in for y, here's what he looks like. 0 equals 1/2 x squared plus 1/2 x minus 6. I just plug 0 in for this y coordinate right there. Okay? And now we've got to figure out what that is. Okay? What do we do first? We hate what? Fractions. We hate fractions. Let's multiply everything by 2 and get rid of those fractions for me, okay? So 2 times 0, 2 times this, 2 times this, 2 times this, right? What's 2 times 0? 0. What's 2 times 1/2 x squared?
1.
Just 1x squared, or I'm just going to put x squared instead of putting the 1 in front. What's 2 times 1/2 x? 1x, okay, or just x. And what's 2 times -6? -12. Okay, now, this guy is a what?
Number.
What is this thing right here?
X cubed minus 12.
It's x squared plus x minus 12. Nope, you can't put this together. It is a what? It's a trinomial. It's a simple trinomial, right? Do you remember doing that?
Sure.
Simple trinomial, okay? So we're going to break this simple trinomial down into 2 pieces. You remember doing this way back when?
Yeah.
Okay, we're going to be doing this a lot in chapter 3. Okay, we're trying to multiply to get a -12, but when I add them gives me, what's that number in front of that x?
1.
1. Multiply to get -12 and add to get 1.
3 and 4.
What combination of 3 and 4?
4 and -3.
Positive 4, -3. Okay, let's check that. Does positive 4 times -3 give me -12? Yes. Does positive 4 minus 3 give me positive 1 when we add them? Yes. Okay, now the last thing I have to do is set them equal to 0. Okay, so if I say x plus 4 is equal to 0, how would you solve for x?
Subtract 4.
X equals -4.
Subtract the 4, so x equals -4, right? Okay, and if I do the same thing, x minus 3 equals 0, I would add the 3 over. Yep. Add 3, so x equals positive 3. Now, FYI, whenever you have these 2 little bubbles in here,
You forgot to
it's
put
always
negative.
just going to be, what?
In front of the 4, you forgot a negative.
Oh, I forgot the negative on the 4. You're right. Thank you. I can't do that. Here we go. Let me fix him. X equals -4. Okay? FYI, when you have this stuff inside of here, those little bubbles, it's always just going to be the opposite sign. Yeah? So if it's x plus 4, it will be x equals negative 4. If it's x minus 3, x equals positive 3. We have two x-intercepts. If I put those into coordinate points, this would be the point like negative 4 comma 0 and positive 3 comma 0. Those are my x-intercepts. This one's my y-intercept, okay? We're going to plot those on our graph, and then we'll be done. Okay? Negative 4 zeros, this guy right here. Positive 3 zeros, that guy right there. Okay, now, tricky question. Is this point right here going to be the vertex?
No.
How do you know?
Because
Is that the lowest point?
No.
No. I mean, yeah. How do you know that's not the lowest point? Or how do you know that's not the vertex? He guessed. Great. Anybody else? Want to take a stab at it?
oh, alright though.
You're right. But why? Why is that not the vertex?
That was literally a half question.
Yeah, okay, so look at Michael. Michael's saying, okay, if this is the vertex, then this has to be the same distance and this has to be the same distance, right?
They're not.
But they're not. So the actual vertex
Is
has to live
0.5.
where?
It's 0.5.
On over here or over here?
That side.
On the left side, right? A little bit to the left because that would make him more even. So it's going to be like down over here somewhere, like here. So if I connect them, he's going to go down and he's going to hit the 6 coming back up. Does that make sense? Okay? So that's what my parabola is going to look like. And we have successfully found the x and y intercepts right here. Those two guys. That's what he's looking for. Okay? To find the x and y intercept, plug 0 in for the opposite. Yeah? And then you graph the thing. All right? This looks like a parabola. Okay, moving on. That's what he will look like.
Wait.
Wait.
Bucks will be back.
You put this back on. I put it on backwards.
Romeo IP.
What?
IP.
EP?
Yeah.
Okay, moving on.
What? Everything.
X and y intercepts are great, but most of the time we will end up just looking for the x intercepts, okay? X intercepts tell me a lot more about a graph than a y intercept. The y intercepts are great, but not a whole lot. So when it's asking me for the solutions, your mom just emailed me again just now. When it's asking for the solutions of a function, if it says find the solutions, what it's asking for is the x-intercepts. You gotta listen. It's asking for the x-intercepts. Solutions are the same thing as x-intercepts. If it asks for the roots, guess what it's asking for? The x-intercepts. If it asks for zeros, you guys had that on your last quiz. What's it asking for? The x-intercepts. All four of those things mean the same thing. Solutions, x-intercepts, roots, zeros. They all mean where he's crossing the x-axis. Yes? Okay. Example 2. Find the root. What does root mean again?
X-intercept.
X-intercept. They're trying to find the x-intercept of this function right here. Okay? How do you find x-intercepts of a function?
Plug in 0.
Plug 0 in for?
Y.
Plug 0 in for y. Okay, we don't have a y in that function.
But f of x is y.
F of x is y. So we're plugging 0 in here and we're solving. Okay? We have 0 equals negative 2x plus 10. Oh, they say that this is a linear function, by the way. How do you know it's
Subtract
linear?
10.
How do you know it's linear?
Because of the x.
X equals Y.
This guy's parent function would just be y equals x, which is a linear function, right? Okay? All right, so we're solving for x here. How do you solve for x in that case?
Find what 10 is.
Subtract 10.
Divide by 10?
Divide by
You can subtract 10. I am tempted to add the 2x over because then that makes everything positive, yeah? You can subtract 10 if you want to. I don't care.
Well,
2x
you'll be
equals
dividing
10.
by negative 2 anyway.
Right,
so-
right. And then you divide by 2, so x equals
5.
5. What did we just find? This guy is the
Root. Or the x-intercept.
x-intercept or the root or the solution or the 0. Those all mean the same thing. That is 5. 5 is the answer. So they say find it using algebra, but then also find it by graphing the function. Okay, so instead, we're not going to look at 5. We're going to graph this function instead now and see if his x-intercept is 5. How do we graph a linear function? Like how do we graph negative 2x plus 10? Start at 10, right? We start up here at 10.
Up
And
to-
then we go
No, down to.
down 2 over 1, 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 etc. He's going to look like that. Okay? Now, we were trying to find what again?
The X
The x-intercept, and we said it was 5. Is the x-intercept 5?
Yeah.
Yep. So we've two different methods we've used to solve that it was 5, right?
Yeah.
Okay, we can graph it, or we can plug 0 in for the y and find that x-intercept or the solution is 5. Yes? Okay, moving on. Okay, last one. We're going to go back up to that equation, the punting example from above. And the equation for that, write it down below here, is negative 16x squared plus 10x plus 2. Okay? And we said that when we punt this ball and it follows that path, it's not going to be in the air very long. Like less than 2 seconds it's in the air. Okay?
That's a small punt.
Yeah, I know. That's not a very good punt, right? Okay? Or maybe it's, I don't know. I don't know.
Mine's better.
It sounds like it's like one of them ground level punts, right? Like where you're trying to recover the ball. Is that a thing? Can you do that? No, you can't do that when you're
That's a
punting.
kickoff. That's a kickoff.
Can you do like a
You mean onside?
onside kick for punt? Can you do that for a punt?
Possibly.
That's not a punt. That's
Can you do an
You
onside
can.
punt kick?
You
I don't
can.
know.
If
That's
you
what it
punt
sounds like
you
anyway.
It's a
hit person.
kickoff.
Anyway, all right, moving on.
You
I
actually
know what I'm
can.
talking
All right,
about.
so let's. Yeah.
If you punt it and it hits a person, you can catch it. and run.
There's this one play where this guy he
No, but
punts
we're
the
getting off
ball,
track here.
but the guy blocks it and
Uh-huh.
it shoots up, and the punter catches the ball and runs in for a touchdown.
Yeah, well, that one wasn't.
Okay, all right, moving on. Here we go.
That wasn't
Find
funny.
the zeros. Finding zeros. Let's get back on track here, guys. Come on. It says graph the function from the punting example above and use the graph to estimate the zeros. What do these zeros represent? Okay, so this is a really ugly parabola. Okay, and one thing that to find the x-intercepts, we would plug 0 in for y, right? So we would end up with something that looks like this, right? Okay, and what is this guy called?
Complex.
He's a complex trinomial, okay? And we tried to do this 6th period, and he actually doesn't factor down to a complex trinomial very good. So instead, we're going to have Desmos graph it for us here in a second. But let's go ahead and write out the y-intercept, okay? So we're gonna lead to a dead end here because we're not gonna be able to factor it down, okay? And actually, to find the x's, we would have to use something called the quadratic formula, which we don't know how to do yet.
I do.
Okay, great.
I do.
All right. So we're going to do y-intercepts now. Negative 16 times 0 squared plus 10 times 0 plus 2.
Miss Temperature.
What's the y-intercept going to be?
We learned that quadratic.
I know, you did in Algebra 1. That's fine. Y is going to be 2 because the zeros are going to go away, right? Okay, so it's going to cross the y-axis at 2. So let's plot this. I'm going to say this top part right here is 4. That means this middle is 2. This guy is going to be 3, and this guy is going to be 1. I'm gonna make the y-axis a different scale. Okay. Now, what is the y-axis? What do the y's represent again? The height of the ball, right? Okay. So the height of the ball is the y-axis. What is the x-axis representing? The time that it takes for the ball to hit the ground. Okay, now we're going to graph this thing and you're going to look at it and say, like, what the heck is happening with that punch? But keep in mind that this distance here is not representing distance longitudinally. It's representing the time that it takes. Okay, so we'll talk about that here in a second. I went ahead and I had Desmos graph this for us, and here's what it looked like. Let me move him up here.
OMG.
Woo! Move up here. This is what he looks like. That's what? Okay, so there he is.
Like, punted it right
Who
in.
punts it straight up like that?
And when we look at this graph, we see that the y-intercept is 2, right? Didn't we say that? The y-intercept is 2, so we're going to put a y-intercept at 2 right there. And the highest this thing goes, this point right here is at 0.3 comma 3.5. So I'm going to go 1 is here. 0.3 is going to be about here. And we're at 3.5, so about there. That's the highest that this ball goes, is at 3.5. Okay? And then it's coming back down,
This is a weird
and it's hitting at 0.784, right? Which is this guy right here. 0.784, and that's where he's touching back down again. Okay? So let's draw this, and let's interpret this graph a little bit.
You already know Coach be mad about that one.
You think so?
Yeah.
Yeah.
I don't know. Maybe it's just like a really nice bullet like shot
Yeah,
across. I don't know.
maybe they're on like the 10-yard line or something.
Right. Okay. There you go. Okay. So here's what's happening. Why for one thing are we starting at 2 and not at 0?
Because it's the lioness.
What?
You kick it right to 2 immediately.
What do you mean? No, not quite.
He was standing on something.
Not necessarily. When you punt the ball, is the ball on the ground by the time your foot
Oh,
hits
that's where
it?
his foot is.
Right, that's where his foot is. Like you kick the ball and you're like 2 feet in the air by the time that your foot touches the ball, right?
Yeah.
Okay? So that's what's happening. We're not kicking from the ground. This isn't a kickoff. This is a punch, right? So we're 2 feet in the air by the time we hit the ball. And then it's going up and it's coming back down. Now keep in mind that this does not represent the horizontal distance. It's not going up and then coming straight back down again. That's the time that it takes. So what could be happening is if we graph the height in relationship to the length, it could actually end up going like that, right? But it's not taking a very long time to get there. Does that make sense? The time it takes is very short, okay? So what is this 0.784 representing?
The time
This is the time that it takes for the ball to
to the ground.
time for ball to touch ground. So that ball is not even in the air 1 second, 1 full second by the time it touches the ground. So it might be a bad kick, or maybe it's just a bullet and it's going really fast by the time it touches the ground. We don't know for sure. Right?
If his foot
Okay.
is at 2, that's like 2 feet. So
Right.
it would have gone up 3.5 feet in the air.
It would have gone
I
up
think
like
3.5 feet in the air is the highest. So it kind of looks like maybe it's a bullet, or it's just a really bad kick. I don't know.
Football is probably more than 5 seconds.
into the
I
air
don't think
from
so.
the foot.
I don't think
bet I
so.
could.
I don't think so.
That is so low.
So anyway, okay. Now, what is another name for this 0.784? What's his name?
The vertex?
This is the, it's not the vertex.
I have no idea.
What's another name for 0.784?
Intersect.
This is the x-intercept, or the 0, or the root, or the solution. Any of those mean the same thing. Solution, okay? So, graph the function. Use the graph to estimate the zeros, and then what do the zeros represent? We've done that over here. The time for the ball to touch the ground, yeah? Okay? All right. Before you guys stop this video, I'm going to pass out their homework assignment, and I'm going to explain some things really quick. So don't stop the video. Here you go. I'm going fast.
Oh, dude, all?
Yes, we're doing all both sides.
Oh.
All both sides. That's not too bad. Most of them are actually linear functions. So there's that. Okay. All right. So here's the deal. On your homework assignment, we're doing all both sides. Okay. And let's look at the instructions here. Okay. On skills practice, I'm looking specifically at skills practice. It says find the x and y intercepts. So as you're going through this, make sure you're labeling like x-intercept, y-intercept, and you're telling me what each one of those are before you graph it. Okay. Tell me what the x-intercept and y-intercept are for each one of these graphs. Okay. How do you find x-intercepts again?
We point that
0 for y. How do you find y-intercepts?
0 for x.
0 for x. Okay, now, this is the weird part that I don't really agree with. I should fix this at some point. But 4, 5, and 6 says solve each equation. What does it mean to solve?
Solve it.
Find the solution.
Yeah.
Which is the
And what's a solution?
x-axis.
Is the x-intercept, right? It means find the x-intercept, okay? Solve each equation by graphing its related function. For some reason, they have already plugged 0 in for y, right? They've already plugged 0 in for y. So 0 in for y, 0 in for y, 0 in for y, okay? So keep that in mind, that really is like saying y, but they've just plugged 0 in already for you, okay?
So it would just be that one.
So you're just finding the y-intercept.
X-intercept.
So you're finding the x-intercept. So you're plugging 0 in for y. You're doing what they've already done kind of for you, and you're graphing the thing.
So
Okay.
to solve that, the y-intercept would be 0, and x would be whatever you got to solve.
Can you not blink off?
What do you mean?
Dude, Jonas can't.
If you solve that where the 0 is already in there, you're finding the x-intercepts. Yeah.
But where would that be?
On the x-axis.
So it'd be, if it's 1, it'd be 1 on the x-axis.
Jonas can't blink.
Yes. Okay. All right. Same thing on the back side. Make sure you're labeling the x and y intercepts on each. And then down here, keep in mind that these are each y, okay? Now, there are only 2 of these that are non-linear functions, okay? So let's talk about those really quick. 3 on the front side. This says x squared minus 1. What is his parent function? Kind of like what we were doing the other day. Y equals x squared, which we know looks like a parabola, but what is the negative 1 doing to it?
It's moving it down 1.
It's moving it down 1. That could maybe help you for graphing this thing, right? Okay? You can finish that one. But let's go to 3 on the back side. So write that down and let's go to 3 on the back side. This is another function that is not linear, because what is his parent?
It's the parabola.
That's a x squared again, right? Okay. And let's talk about like how you would solve this and set this equal to 0. If I plug 0 in for y, I'm finding the x-intercepts. What is this piece on the right side? X squared minus 4x plus 4. What is that?
It's a complex.
It's a simple trinomial, right? A simple trinomial. What do you multiply together? Because there's no number in front of the x squared, right? What would you multiply together to give you 4? But when you add them, give you negative 4.
Negative 2, negative 2.
Yeah, x minus 2 and x minus 2, right?
Yeah.
And if you set x minus 2 equal to 0, x is actually equal to 2, and x is equal to 2 again, right? Wait a second. Those are the same number. X equals 2 is my x-intercept. So what does that mean?
I don't know.
No,
It's
it's
just-
not just a line. Normally my parabola looks like this, and I have like 2 places where it crosses.
That would be where it starts.
What do you mean by where it starts? That is the
Starting
The
point.
vertex.
vertex point. Yeah, that's what the vertex point is, right?
Yeah.
Okay. Now, what is the y-intercept if I plug 0 in for the x's? What's the y-intercept going to be?
4.
Gone, gone. The y-intercept's just going to be 4, so he's going to touch 4 over here, right? Okay.
So it's just normal parabola.
And he's a normal parabola, and he looks. I also put a dot on this side. Do you see why I can put this dot there also?
Yeah, and then
Yeah,
it'd be
because he's the
over
same on the
one,
both sides.
up one, though. It'd be over 1, up 1 from the vertex.
Yeah, right. So it will touch those 2 places as well, right? Okay, so there's that. Okay, so that's what the graph looks like, but make sure you label what the x and y intercepts are. Okay, all right. The rest of them are linear functions. They shouldn't be too bad. Okay, are we doing okay so far?
If I put this,
Okay.
okay, if I do it
What
like
was
this,
the other
it
one?
would be okay.
Just come,
That's fine.
Go back.
That's fine. What?
Go back till it gets
May I go to the bathroom?
Yes. Okay. Good. Any other questions before I stop the video? All right. Bye, people that are watching this video.